All right, this lesson is about simplifying radicals. So a little vocab to start out. A radical is an expression that includes a root symbol, like as you see here for the square root, or as you see here with the 3 there for a cube root. Radicand is the number inside the radical symbol. So like in the example down here, square root of 50, the radicand is 50. Simplifying a radical means writing it in its simplest form. So the big things to look out for are no perfect squares or cubes, if it's a cube root we're talking about, remains inside under the root, and no radicals remain in the denominator if there's a fraction. So the first thing that you're going to want to do is prime factor the radicand, which is break the number inside the radical into prime factors. All right, so we're going to take this into effect with this first example. So we're going to simplify square root of 72. So the first thing I want to do is I want to break down 72 into a factor tree. So I get 2 and 36, and then I break that down to 6 and 6 is what I chose, 2 and 3, 2 and 3, okay? So this means 72 is the same thing as 2 times 2 times 2 times 3 times 3, just by looking at what I just did the factor tree. And we're going to finish this later as we discuss what we need to do next. All right, so then what we're doing is we're going to group perfect squares or cubes. For square roots, group the same 2 factors in a pair. For cube roots, group in 3s. So we're coming back to this example. Okay, so we determined that 72 was, there's 3 2's multiplied together, and there's 2 3's multiplied together. So that means the square root of 72 equals the square root of this, 2 times 2 times 2 times 3 times 3, okay? Which then I went ahead and I just wrote it a different way. And I said, okay, so that means I can take square root of 2 times 2 times the square root of 2 times the square root of 3 times 3. And I did this just to show the pairs. Totally get it. You don't have to write it that way. I was just showing you what goes together. So then next, we want to move groups outside the radical. So each pair of numbers becomes one number outside the radical is what's happening. So we're back to our example, okay? So we now have got this. We had our square root of 72 equals the square root of 2 times 2 times 2 times 3 times 3. I broke it down to, this was 2 times 2, square root of 2, and the square root of 3 times 3. So now what we're talking about is we're going to pull things aside. So we know the square root of 2 times 2 is equal to 2. Square root of 2 is simply square root of 2. And the square root of 3 times 3 is equal to 3. Okay? So then I can rewrite this and say, okay, then my square root of 72 is now equal to 2 times 3 times the square root of 2, which then, yes, I can simplify this to 6 square root of 2. And that would be the simplified radical form of square root of 72. So again, make sure the radicand has no more perfect squares in it, and make sure there are no radicals in the denominator. So now we're going to do a problem that has a denominator. So you're going to do it the same way. So when I broke it down, I got 3 times 3 times 2 for 18, and I got 2 times 2 times 3, okay? So then now when I do this next step, this simplifies to, I have my 3 times 3, and I've got my 2 times 2. So I just keep going through the process. So this gives me 3 square root of 2 over 2 square root of 3. Okay, so here's the deal. We cannot have a radical on the denominator. So how I get rid of the radical on the denominator is I'm going to multiply the top and the bottom by whatever that radical is, okay? Because the whole point is I'm going to make things go away. So then now I have 3 square root of 2 square root of 3, and we're going to simplify that. And then I have 2 square root of 3 square root of 3, okay? Which gives me, we multiply what's inside there, so 3 square root of 6 over 2, right now, square root of 3 times 3, and we've talked about this. So then the next thing I'm seeing here, 3 square root of 6 stays there, and on the bottom, then I'm going to get 2 times 3, because that's what I pulled out, which then I have 3 square root of 6 over 6. But I want to simplify because they're going to ask me to simplify. And when I simplify, I get square root of 6 over 2 because of the 3 and the 6. And there's a 2, there's a 1. So then my final answer is square root of 6 over 2 to get there. All right, square root of 98, if you do your factor tree, comes down to 7 times 2. Well, then here, 7 times 7 is under a root, square root of 2. So this gets a 7. There we leave the square root of 2. And that's the simplified form. Square root of 200, this is one of those that if you can identify a perfect square, like 100, you can avoid the prime factorization. But the prime factorization is simply 2 times 2 times 2 times 5 times 5. So then we split it up, 2 times 2 times the square root of 2 times the square root of 5 times 5. Start bringing things out, 2 times square root of 2 times 5. And then you get 2 times 5 square root of 2. And you're left with 10 square root of 2 as your final answer. Okay, so definitely want to do an example of a cube root. So now we still do the prime factorization, but we're talking about cube roots, which is, this is just 3 times 3 times 3 times 2. Again, we're playing the game for a cube root. To pull it out, we have to have 3 of them, okay, which we do. Okay, and then now, again, I can pull out a 3 from here, and then I have a cube root of 2. And I can't go any farther. That's my final answer. Okay, got to tackle it with variables. So now what I will do, and you'll see me do this in variable land, is you will see me change them to exponential form. So like the square root of x equals x to the 1/2. Okay, so square root of x squared would equal x, power goes on top, root goes on bottom. Square root of x cubed would be the same thing as x to the 3 over 2. Square root of x to the 4th would be the same thing as x to the 4th over 2. So again, you're talking about x to the power over the root when we're changing it to exponential form. And we're doing this because this is how we clean it up. So when I do that here, I now have x to the 2 over 2. I have y to the 4 over 2. And then I have z to the 1/2. So now I'm going to simplify those fractions. So this is just x to the power of 1, or x. This is y squared. And then I still have the z to the power of 1/2. So now I'm going to put it back in radical form. And when I do that, my x and my y squared stay on the outside, and my square root of z stays underneath. So again, the big kicker here is changing them to the exponential form to clean it up. And of course, we need to have problems where we do all of it together. So now we're dealing with the 72 as well as some variable stuff. So again, we know what 72 is because we did it at the very beginning. So we know that this is 2 times 2 times 2 times 3 times 3. So we can deal with that. We know from originally the problem, this gives us 6 square root of 2. Well, now we've got to deal with these variables in there. So we know from previously, so this is going to be the square root of x to the 4th equals x to the 4 over 2. And the square root of y cubed is equal to y 3 over 2. Okay, so some of this is clean, some of it's not. So what I would do is if I'm doing the square root of y cubed, I'm going to see that as the same thing as square root of y squared times the square root of y. I'm going to split them up. Again, this is where knowledge of that rules of exponents helps out. So when I do that, when I split them up, then I get the square root of y cubed is the same thing as y square root of y, because I can pull out one, can't pull out the other. So then now when I put all these together, because again, reminiscing back up here, this is simply x squared on the outside. So now when I put them all together, I have a 6 outside of the radical. I have an x squared outside of the radical. I have a y outside of the radical. And I'm left with a 2y underneath the radical. Okay, so just another example. So this breaks down to 50 is 5 times 5 times 2. So we can pull that out to simply a 5 square root of 2. And then over here somewhere, because I'm like, if I think of square root of a cubed is the same thing as square root of a squared times square root of a, which gives me an a square root of a. So there I didn't even put it into exponential form. You take your choice. And then square root of b to the 6 is the same thing as b to the 6 over 2, which equals b third. So then now I'm putting these all together. Outside is a 5, an a b cubed. Under is a 2 and an a. And I'm done.